Hey everyone. Right, so we're going to be talking about try-except blocks. Now, in Python, there are a lot of different errors that you could come across, but sometimes those errors are not because your code is actually faulty. Obviously, if they do, you need to sort those out. But sometimes you need to build your code in a way that might accept certain unpredictable inputs. Like in Houdini, we often would maybe we're going to run a piece of code on an object that someone selects, but maybe the user has gone and selected an object of the wrong type or something like that. So you need to build your code so that it's robust and it can sort of handle different problems coming in. And that's not always, it doesn't always need to end in you just raising an error and exiting the code and basically saying, I can't do anything. Sometimes you usually expect one kind of input, but if they do a different kind of input, like they feed you a volume instead of geometry, you are happy to actually build a separate section of your code to handle the volume instead of the geometry. So what you can do sometimes, in that case, it's probably better to just test what type of geometry it is and do an if block. But let's say you have other scenarios where you want to try do one thing, but if it fails, you then want to default to a different block of code. And that's what a try-except is for. So I'm going to show you an example over here. So we're going to build a list, and I'm just going to call it fill it with 1, 2, 3, 4. And then if I try to so I'm going to create a variable called foo and make this be equal to, I'm going to extract an item from the list, my list 5, okay? And then I'm going to print foo. Now, this is going to error. And the reason why is because I'm trying to grab index 5. Obviously, this has only 4 indices, of which it would be 0, 1, 2, 3. So it only goes up to 3 anyway. So I'm trying to select a number that is 2 indices outside of the range of this list. Okay, and that's exactly what it tells me here. It says there's an index error, and it will explain what that means, and it says that the list index is out of range. Okay, so that's exactly what we're doing, is we're asking for an index from a list that is out of the range of that list. Now, what if I know that there are some scenarios, in most cases, my list, however I've chosen to populate this list, will have up to index 5, so at least 6 items in the list. But that there is a rare exception where it will only have 4. And in that case, I want to do something different. All right, so maybe I just want foo to then be equal to the last number in the list rather than specifically index number 5. So then we can use a try and except block. So this is really easy. We just type try : and then of course we have to tab this in because it is a block. So it's essentially saying try run this block of code. And it does not have to just be a single line, it can be a whole block. And within that block, if there is an error, then it will not actually execute that block. So it sort of does like a test execution of that block. And then if it succeeds, it'll proceed as though it has executed that block. But if it errors instead, it kind of almost backs up a little bit and says, right, I'm not actually going to do that. Pretend I didn't do that. And then it moves on to the except block and does that instead. Okay. So this is what it would look like. So try : then one block, and then except : and then the other block. And this block will happen now whenever this one throws an error. So maybe in this block, what we want to do is say foo equals my list and then -1 as an index. So regardless of the length of the list, it will always select the last one unless it can find an index number 5. So if there are 6 or more items, it's going to specifically grab the 5th one, but otherwise it's going to grab the last one. Okay, and now if we print, it's going to get 4 because that is the last one in the list. In other words, it tried, it failed, and so it did the exception. Now, of course, if I go 5, 6, 7, 8 and add a whole lot more in there, now it's going to grab 6 So you can see it's not grabbing the last one, it is just grabbing 6, because that is what this one is telling it to do. So it tries and succeeds, so it does not do the accept. Okay. Now, try and accept with no specification here is not very good practice. You can do it, but what this is essentially saying is if this throws any kind of error, then you should just do this instead. And the reason that's not good practice is because maybe there is an error in your code and you're not going to notice it now because you're accepting every single error and just doing something different. It's very hard to debug in that case. So usually you want to say, well, if the list is the wrong length, that may mean that the user has given me a different type of geometry that I want to handle in a different way. But what if there's a name error, like the list actually doesn't even exist? Then that means there's maybe a problem in your code. So the accept takes an actual, like it takes some extra input. And that is that you can feed it, so you just put a space in and you feed it the error type. So in this case, we call it an index error. You'll see it's exactly how it was spelled in that error message that came up. It's a capital I, a capital E, and no space in between. You must spell it exactly the same, then it will pick it up, okay? And you just type it like that. You don't have to put it in quotes or anything. It's just index error. Also note that Houdini has its own internal errors that are unique to it and not in Python. Usually they will be who dot and then something like attribute error or something like that. So there's a whole bunch that are within Houdini. I'll show you those as we progress. But for now, just within Python, there are its own internal errors like an index error. So now this will be fine and say, okay, it's still going to work fine. It's still going to print a 6 there. But if I make my list shorter, then it's going to print a 4. But now let's say I renamed my list. So I'm going to just say, imagine I'm looking for my list 2, but instead I'm feeding it something called my list, right? Then it's going to throw up a name error instead of an index error. So that's why it's better that this accept is not just global, because otherwise it's not catching anything. If I take this away, then it's just going to ignore that. Oh, and here it's even saying it failed during the second one, because during the accept block, because it can't find that. But anyway. So you really want to list these, and if maybe there's also, if it has a name error, then there's a different thing you want to do. Well, then of course you could do that as well. So you can have another accept block, which is accept name error, and in that case you want to maybe print list not provided, or whatever the case is, whether that's like maybe the user is actually should have provided the list. I'm not sure where this list would be coming from. Okay, obviously here I'm just generating it myself, but this is just sort of a small example. So now name foo is not defined. Oh, okay. We haven't initialized foo. So there's another type of error, but again, that's another type of name error. But what we can do is say foo equals none over here, and then that should be fine. So we're basically trying to do this. We're failing because the list doesn't actually exist, but we're failing in a way that is a name error, not an index error. So instead of trying to do this part, we are just saying, hey, look, you've not provided me the right list, because I'm looking for my list 2, and you've clearly not given me that list. So instead I'm going to just print a warning, and then this is a separate line that has nothing to do with that block. It's just afterwards, so it's always going to print foo, but foo in this case is none. Now there are another sort of set of extra blocks we can add onto a Tryexcept block, one of which is an else. So you can add an else at the end of any number of accepts, and what this does is essentially runs whenever this succeeds. So in other words, it's saying try this, and then if you error in this way, do this. If you error in this way, do that. But if you don't error at all, then do this. Okay? So it's almost expecting to error, but if it doesn't, so if this succeeds, then you can do this. So sometimes you may want to actually call something, like call that index and try and store it in a variable before printing it. So maybe you want to put the print foo in the else. So you're only going to print it if you find it Otherwise, if you fail, then you're going to do something different and not do the print function. Okay, so you could do that, for example, and put that in there. Now it's going to print the error, but not print foo. But if it succeeds, so let's say we go, we're now looking specifically for mylist, not mylist2, then it's going to, it's failing there because this is out of range. So it's creating this, but it's not actually printing it because the else will only do it in that, if that succeeds. So now, even though it's setting foo to be equal to something, which is 4, because this ran an error, an exception block ran, the else will not happen. Now, if we increase the list, so 4, 5, 6, 7, then it's going to print because basically the try went successfully, so it also does the else. Okay, so it's like these two are paired together and then these run independently. There is another one called finally, which you usually put right at the end here, and it basically says no matter what happens when this tries, then either one of these errors and also after the else. So no matter what happens here, the finally is always executed, right? So we could print end, for example, or something like that. And then no matter what, it's going to print end, whether it succeeds, fails, does anything, so we could shorten this list. It's going to just print end, even though it basically failed with an index error, set foo to be equal to the last number, did nothing else, skipped the else block because it didn't succeed. It's still going to do the finally block. Okay. Now, honestly, I've never used a finally block in actual code. I don't really see the difference between doing that or just printing end after this is all run, because this is also always going to execute as soon as it reaches the end of this. So it's really just, I think, a way of neatening up and making sure that as part of this block, if we still want to run something at the end so that it looks visually like it's clearly linked with all of this, then you can put it at the end here. Maybe there are other uses for it, but yeah, I've never had to use that, but I do use try and then except all the time, and then occasionally I'll use an else statement along with that. But the finally, yeah, not really often used, at least by me in the code that I've written. Okay, right. So that is Tryexceptblocks. I know this seems a little advanced, at this early stage, but you're surprised at how common you need to do this. So even in very simple code, you really often need to do like a try except in some way. Otherwise, because if you come up with an error, it kills all the code. Like it just stops and it won't let it move forward. So you have to kind of make decisions about how to handle all these different errors depending on the input that comes in. So I've found that in Houdini, you use a try except very often, even with very simple code. Okay, so I'll see you guys in the next lesson where we're going to do loops, another kind of block.